what I will teach today is the relationship between angular velocity and the linear velocity. You know, angular velocity is a velocity of a body moving around a circular path. While linear velocity is a velocity of a body moving in a straight path. Now, the formula of angular velocity is W equals to theta all over t. This is omega sign. We use this omega sign, which is W, to represent angular velocity. Then we use theta to represent the angular displacement, angle turned. Angle turned, you know, look at this circle now. This is angle turned of a body. Started from here and move here. So the angle turned is the theta. It represents the theta, angle turned, or angular displacement of this body going around a circular path. Okay. Now, and this angle turned is also equals to S all over R. S all over R. Remember, this is angular velocity, the velocity of a body moving round a circular path, just like this circle. The velocity of a body moving around a circular path. And this is theta, representing the angular displacement, the angle turned of this body in a circular path. Yt represents the time it has taken the body to turn through. Now, this angular displacement now can also be gotten from theta equals to S all over R. Why this one is presenting this angular displacement or angle turned through. Then S is representing the distance of this circumference. Distance moved in this circumference. Then R is the radius of the circle. Radius of the circle. So, if a body complete one circle, if a body complete moving from here to here, which is it has moved to 360 degrees, okay? But in angular velocity, we use the unit of radian. Therefore, the unit of angular velocity is radian per second. So we measure this angle turned through in radian, okay? So instead of this body, if this body complete one circle, it has turned through 360 degrees. But in radian, we say that it has turned through complete 2 pi radian. We complete this circle, which is 360 degrees. In radian, it is 2 pi radian. We say that it completes 2 pi. In other words, if a body completes one complete revolution, meaning that it has completed one circle like this, or one cycle, one complete revolution is equals to 2 pi radian. Just like saying one complete revolution is equals to 360 degrees. In pi radian, it is equals to 2 pi radian, meaning that 2 pi radian is equals to 360 degrees. In conversion, if I want to combine radian in degrees, this is the conversion. So one complete cycle is equals to 2 pi radian or 360 degrees, okay? Now, we say that that angular displacement now is equals to S over R, meaning distance all over radius of the circle. Remember that one complete circle is one circumference. So in mathematics, circumference of a circle circumference of a circle is equals to 2 pi r. Circumference of a circle is 2 pi r. Now, one complete circle is 2 pi radian, and this 2 pi radian is representing this angle turned round. It is representing pi, it is representing this theta. It is representing theta, just the angle turned through. It's representing theta. And if it's one complete cycle, which is 2 pi radian, therefore the angular displacement there will be 2 pi radian, which is our theta now, okay? Which means the theta is equals to 2 pi radian when it completes one cycle, which means the circumference of this circle now is equals to 2 pi r, which means this 2 pi is theta now, okay? Which is theta r. And the circumference of a circle is the distance of the circle now, right? The displacement of the circle, which we may represent as s. Let s represent the circumference of the circle, the distance turned through, the angular displacement turned through. Making this subject of formula, we now have theta equals to s all over r. That is how we got this. Now, let us move on to relate this angular velocity and the linear velocity. The angular velocity is equals to theta all over t, angular velocity, angular displacement, and the time. Then our linear velocity is equals to distance all over time. Linear velocity, distance moved, and the time. Then our angular displacement is equals to distance all over r. So making s subject of formula, we now have theta r, making this subject of formula. Then making the same distance here subject of formula from this, we now still have s equals to vt, okay? Right? Therefore, if s is equals to this and s is equals to this, therefore theta r is equals to vt. But from this formula, angular velocity is equals to angular displacement all over time. We now, from here, we now have theta equals to wt from here, making this subject of formula. Therefore, we now replace this with this, okay? We now have wt replacing with this, and the r equals to vt, okay? Moving on, remember the relationship between, what we are treating is the relationship between angular velocity and the linear velocity. Now, making v subject of formula, we now have v equals to wtr all over t, okay? Time cancel time, it will now remain only v equals to wr. That is linear velocity equals to angular velocity multiplied by radius of the circle. So this is the relationship, this formula is the relationship between angular velocity and the linear velocity. Thank you for watching. Please subscribe so that any new video that comes in, you get it. Now, what will come in next video now is the calculation involving this formula. Thank you for watching.